Okay. Good evening. Good evening, students. Can you hear me? Okay, great. Yeah. If possible, please switch on your camera so we can, this is our first time, right? Meet online, and we may not have opportunities to meet face to face, right? All right. Yeah. So it's 7 p.m. So we should start our first seminar on this course, applied forecasting, right? Just a quick check. Have you all learned this forecasting or R before? You can unmute yourself and talk. Okay, I see a few of you. You learned some this knowledge about forecasting before, right? Okay. Someone says not in R. Okay, yeah. I learned this knowledge in my master's maybe 15 years ago, and I taught this course for a few times. But with R, this is also my first time using R. Okay, I use other software to do time series analysis. Okay, okay. So anyway, let's learn from each other. Let's learn together. Okay. All right. Maybe you don't know me, and this is my profile, and uh, I have been with SUSS for a few years. I think this is my ninth year. Okay. Yeah. My education background, I have a bachelor and a master's in economics, and a PhD in so-called operations management, especially with application of operation research. Okay, yeah. So something related to optimization and applications in various business areas. Okay. Yeah, something related to my research. Yeah, I'm doing research on operational strategy, operation service operations management, queuing analysis, right, supply chain management, and complex systems in economics and management. Yeah, yeah. I'm also doing something related to risk management, the research. All right. Yeah. The slides are prepared by our course leader, Dr. Wu, Carl Wu. Okay, and so basically, I will go through all the materials during seminars. And so first, let's look at the requirement or some basic information about this course. Okay, so for this course, we have 6 study units. Basically, we have 6 seminars, right? So in the first seminar, we will focus on some introduction or basic knowledges about business forecasting. Okay, we will have a few topics regarding the time series forecasting and how we can use R in time series analysis. Okay. In seminar 2, we will discuss some properties of time series. Okay, we need to do data preparation and what are the key statistics used in time series analysis, and how to decompose a time series into different components. Okay. In seminar 3, we will discuss a few regression models. For example, simple moving average, exponential smoothing, and maybe two uh, parameters, right? With a simple or exponential smoothing or 2 parameters, right? And seminar 4, we will discuss the stationarity of time series, and we will focus on moving average and autoregressive models. Okay. Seminar 5 and Seminar 6, basically we will combine the autoregraph AR model and moving average model. AR, we will have ARMA models, right? And also we will consider so-called the difference of time series and discuss the ARIMA models. Right? We also have maybe seasonal ARIMA models or SARIMA models. Okay. In seminar 6, right, we will discuss dynamic regression models. Basically, you may have a multivariate time series. Okay. And we also consider some heteroscedasticity of the variance. Right? We will focus on the arch and gotch models and maybe some variations of the gotch models. Okay, yeah, so this is the topics for the 6 seminars and the software. Okay, as you can see, we will use, okay, let me use, yeah, we will use Anaconda. So you need to install that in your laptop or desktop, okay? And then within that environment, we will use a Jupyter Notebook. And of course, some data, you can use Excel to open the data and do some, manipulation. And this course, we will use R, right? You use R to do the time series analysis. In particular, we will use a package. I think it is developed by our course leader, Dr. Wu, the TS forecast package, okay, in R. You can also use RStudio. I actually use RStudio actually more often than Jupyter Notebook. Okay, and however, in this course, since we will use I think the codes are written in Jupyter Notebook, so we will use Jupyter Notebook. Okay. All right, so let me check whether you have installed R. What happened with? Okay. Yeah. Have you all installed R, the basic R or RStudio? Okay, great. Yeah, that's great because we will use R, right? And to although the first seminar we will have right some practice and we will do some activities. Okay, and have you all installed Anaconda in your laptop or desktop? R has been installed, right? Okay, fantastic. I see. You mentioned yes. Okay, fantastic. Okay, and so if you have followed the instructions, which you can find in Canvas L01 group, so you should be able to install R and Anaconda, right? In Anaconda, you should install or Jupyter Notebook, right? Jupyter Notebook. And then we will use, sometimes I may demonstrate the process, the activities or examples with maybe RStudio because they have similar, you know, structures in terms of how to write the code. Okay, yeah. So you have all installed R Anaconda Jupyter Notebook. That's great. Or some of you may use RStudio. Okay, RStudio is also a very good coding environment that you can use. Okay. Yeah. Okay, so these are the the basic things, right? But this course, the so-called learning outcomes. So we hope to achieve all the 6 learning outcomes after completing this course. Okay. For example, you can design a forecasting model, right, for to do a time series analysis, and you assess the properties of the time series data, and you appraise the suitability of various forecasting methods, forecasting frameworks, right? Okay, yeah. So these are the learning materials suggested by our course leader. First is the textbook. It's free, right? And but it's optional. Okay, basically I mentioned earlier we will use the packages developed by Dr. Wu to demonstrate how to use various methods, frameworks to analyze a time series. And you can also find various useful materials from our project, right? From the internet. And you should download all the required materials regarding, for example, seminar materials, seminar slides, the notebooks, right? The codes written in Jupyter notebook, and watch the video, right? Prepared by our course leader regarding, for example, how to calculate the variance of time series, how to calculate the auto correlation functions, partial auto correlation functions, and some forecast, right? How to do some forecast, and very useful videos. Okay, so these are the materials. So please do check the announcement, check the materials regularly from Canvas L01 group. Okay. Okay, regarding assessment for this course, you can see we have three components. Uh, I'm not sure whether this is correct information. In my announcement, uh, based on the information from the program, so it says the due date is 23rd, right? 23rd February, actually today, 12 noon. But here the information says it is February 21st. Anyway, so have you all complete the pre-course quiz? Can you let me know? Have you all completed the pre-course quiz? Okay, that's great. That's great. Okay, yeah, wonderful. Yeah. All right, so we have a group-based assignment. We have GBA. Okay, we have GBA, and the due date is almost 1 month from today. Okay, March 22nd. Okay, and the GBA will be 30% of your total score. Okay, participation. Okay, participation. Basically, you need to attend a seminar, right? And attend a seminar regularly from seminar 1 to seminar 6. And you need to participate in activities in the seminars, in each seminar, right? You need to contribute to the discussions, okay? And so this is participation, right? Participation will be 10%. And then ECA, 50%, right? ECA, the due date will be April 13th, okay? All right, so remember the deadline is 12 noon, okay, not during the evening, okay? So it is 12 noon, and whenever you submit your anything to Canvas, right, you need to submit early. Do not submit your report uh, by or exactly on or before the deadline. Maybe you should submit your DBA or ECA at least a few hours before the deadline, right? In order to avoid any unnecessary issues, right? For example, the system may not be stable, right? Or sometimes the system is very crowded, and you cannot upload your documents, right? And sometimes you also need to go through your training report, right? Because you need to maybe make some revision if your similarity score or AI score is too high, right? In order to avoid any unnecessary, issues or plagiarism issues. Okay, yeah. All right, so this is the information about this course. And do you have any questions regarding the assessment, regarding the requirement? So far, so good, right? Okay. So I treat everyone is okay with the information from the about this course and the requirement. Okay. All right. So let's go to the seminar content. Okay. So first, because this course is about applied forecasting, basically how we can apply forecasting techniques, right, to make bad decision, right? And so the questions you need to ask is, so what is first, what is forecasting, right? What is forecasting? Second, and so what is the rule of forecasting, and or why do we need to conduct forecasting, right? How do we forecast, right? Uh, these are questions which you need to consider, right? You need to think about it before you take this course, right? Of course, some of you are doing work regarding data analysis, right? So you have applied or you are applying various tools to do data analysis, right? But the thing is, so so you consider, you take a course, you consider, so what are the key subjects and or what are the key takeaways after I taking this course, right? First thing is, because this course is the forecasting. So what is forecasting, right? So you need to understand what is forecasting, right? All right, so basically, we apply forecasting means you want to predict the future, right? Currently, maybe at this moment, you want to know, for example, tonight. So what is the stock price movement in U.S. stock market, right? Because you know last week, um, the Trump administration's tariff tariff things has been vetoed by the Supreme Court of U.S., right? So now they have maybe some uh, movement, right, in U.S. Maybe tonight, right, the U.S. stock market may have maybe higher volatility or turbulent, right? So we need so now suppose we are taking this course now, so we want to forecast, right? Forecast. So what is the share price of maybe certain stocks, right? For example, Tesla. I think many of you may invest in Tesla, right? So what is the stock price of Tesla today, right? Okay. So business forecast, right? Forecasting is an integral part of decision-making activity of management, right? Management means you need to make decisions, right? The decisions um, may based on past, may also based on your prediction of future, right? So you predict the future, you try to predict the future. So what could be the future, right? As accurate as possible, right? Given the information you have, right? For example, you know the past information uh, based on the past information or historical data. So you want to predict, right? You want to predict. So what could be the situation in the future, right? And with the information, you will make a better decision, right? And with predicted information or a situation, right? You may have a chance to improve uh, the effectiveness of your decision making, right? And of course, uh, sometimes you need to set goals, right? With some future situation, right? You set goals, and you make decisions, you plan, right? You have some action plans, right? Given the goal set for the forecast, basically. So the forecast will help you to make decisions, and a good forecast, maybe you try to predict the future as accurate as possible, which will enable you to make good decisions, right? Okay, forecasting, basically, you can see you want to predict future, right? Which has not been happening. Uh, uh, you only have historical data or historical information, right? So you may need to apply various forecasting methods, right? Or some mature methods, right, to make the forecast. Okay, so in general, we can discuss or divide the forecasting method into two general types. One is qualitative forecasting. Qualitative means you don't use any data, right? And for example, this Delphi method, this says you may, for example, ask the opinions from a few so-called experts, right? You select someone, maybe a few people as experts and ask their opinions, right? And then ask, for example, you ask them, so what is the uh, uh, for example, tonight the U.S. stock market, whether it go up or go down, right? And then you get the results from each expert, and then based on the expert, you make a synthesize maybe based on the opinions. So these are the qualitative forecasting, right? So they don't use any data, right? That maybe based on their knowledge, based on their expertise, or based on their maybe source or opinion, right? Okay. So quantitative data mean quantitative forecasting. So you need to use uh, historical data, right? You need to use past information to make the forecast. Okay. And so because you are dealing with data means you need to apply various data analytical tools, especially we will focus on the time series, right? We use time series to do the forecasting. Okay. This is a very interesting example, right? I think if you read the news, right, this guy actually predict the U.S. election, general elections, and the success rate actually is very high, right? So this professor, right, do a purely qualitative forecasting, right? No data used, right? No historical information used in his forecasting. Right here, you can see he predict the outcome of 9 out of 11 U.S. presidential election correctly, right, since 1984, using his 13 keys, right? These 13 questions, right? And then to answer each of the questions, then he can predict which party will win the presidential election, right? So basically, there are no data related to election required. But now you can see the US election, actually the forecasting method is very sophisticated, right? And the various media, they can predict which candidate wins the election ahead of the final outcome, right? Because they have very mature forecasting method, very sophisticated forecasting method used in election. Okay, so this is a qualitative forecasting, right? Very interesting example. Okay, quantitative forecasting, right? Quantitative basically, we need to use data. We need to rely on the past information. We need to rely on the historical data, right, to predict the future. And because we have data, so we need to apply various analytic frameworks and tools. Okay. So you can see this is a time series. This is a plot of time series. Okay, maybe the horizontal axis is time t, right? And the vertical axis maybe some subject you are interested in. For example, maybe the share price of a company. Maybe, for example, Tesla's stock price. Okay. And we have numerical observations of a subject, okay? And we have forecasting. We need to perform forecasting based on the information, based on the pattern in historical data, right? For example, now this is the share price of a stock up to time this time point, right? Now, suppose you need to analyze this time series to find some patterns, to find some maybe unobserved underlying rules, right, to govern this time series and predict maybe the movement of this in the next maybe 5 days, next 5 months, or even maybe a longer period. Okay. So we need to model the data pattern mathematically because these are data, numerical values, right? So we need to have mathematical models. We need to have various tools and frameworks to extract the information from these data. Okay. Because it's you when you do forecast, right? You predict the future. And future has not happened, right? So you must have a so-called a prediction error or forecast error, right? So maybe for example tonight you predict the movement of U.S. stock market, right? And after tonight, right, and after the close of U.S. stock market, and you will see whether you have how much for product forecast error of your forecasting. Okay. Of course, because this is a time series, we have various methods or frameworks to extract the information from past historical data, and with the information, extracted information, we predict the future. So we may have different types of time series data. Okay, so for example, you may have late in seminar, I think seminar 2, seminar 3, we have stationary time series, we have a non-stationary time series, right? We have maybe have time series with some particular patterns, for example, maybe clear trend, or maybe cycles, or seasonalities, right? So these kind of things. Or sometimes you may have a time series where the data are totally random without correlation, or so sometimes we call it maybe a white noise, right? White noise. Okay. Of course, we want to extract information from the past historical data as much as possible. Okay. And so with the historical the information from past data or historical information, right, we can apply, we can predict the future. Okay. Of course, because it's a quantitative, so we have various compute programs, maybe software we can use, we can apply, right, to do the forecasting. So as long as we understand the underlying theory, right, so we can, as long as you choose the appropriate methods and frameworks, and you can apply various, you can use various software or tools or programs, right, to conduct the forecasting. Okay. Okay. Of course, the application of forecasting, especially because we are doing forecasting in the business world, right? So there are various applications. For example, operations management, right? Operations management, for example, you want to uh, uh, predict maybe the demand, and then you need to use the demand information to guide your maybe production plans, right? Or you predict maybe the raw materials of your input, right? The price of the raw materials of your input, right? If the price, for example, the price goes up, right now, right now you can see there is maybe some tensions between US and Iran. Maybe the oil price will go up, right? So this will affect your input. This will affect your production plan, right? And financial and risk management, right? In financial market, in stock market, right? You want to predict, for example, the stock price movement. You want to predict maybe the uh, 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 the price of maybe commodities, right? In a stock market, right? You want to predict, you want to predict, for example, the exchange rate, right? In financial and stock market, right? This will help you to do a better risk management, right? So improve your risk management practice or effectiveness. Okay. And economics, okay, economics, for example, you want to predict the maybe the GDP, right? You want to predict whether U.S. Will Federal Reserve will lower down the interest rate, right? So these are all the various applications. Marketing, okay, you want to predict maybe your consumer demand of your product, right? And you want to predict the price movement of your product, right? These are various applications of forecasting, okay, in the business area, okay. Okay, because we focus on the quantitative forecasting in this course, okay, we will not consider qualitative forecasting because we may not be expert in, in certain areas, okay. So we need to consider how to what are the key forecasting tasks in business forecasting project, okay. So we need to have basically a subject to be studied. So what are you going to forecast? So what is the subject of interest, right? You want to forecast, you want to predict in future, right? And what is the beginning of the forecast? What is the end point of the forecast? So this is time bound, right? You have a starting point, you have an ending point. And of course, you also need to understand what is the frequency of your forecast, whether it is daily based, whether it is maybe weekly based, monthly based, quarterly based, or even yearly based. And in financial or capital market, you may have high frequency data, right? Even uh, your frequency of cast is very high. For example, every second, right? Every minute, right? You need to do a forecast. Okay, so depending on your subject of interest. Okay. So let's look at these two examples. For example, we want to forecast the daily number of cinema visitors in Singapore, right, from 2026 to 2029. It is a very clear forecasting task, right? Because you can see you want to forecast the daily number of cinema visits. Basically, the number of cinema visits are the subject, is the subject to be studied. And the forecasting begins from 2026 to 2029, right? 4 years, right? Inclusive, 2026, 2027, 2028, 2029, right? 4 years forecast. And your frequency of forecast is daily because you want to forecast the daily number of visitors to cinema, right? And so you can see it's a very clear forecasting task, right? But the second, you can see concert attendance in 2025. Now you can see, of course, you can see the subject is the concert attendance, right? So the number of visitors to attend a concert. Okay, that's okay. But the thing is, in 2025, basically in last year, right? So you don't know when you are going to forecast and what is the endpoint of your forecast. Okay, and we don't know the frequency of the forecast, right? It's maybe it's, if it is maybe just a data point in 2025. Okay, so we say it's not a clear forecasting task. Okay, so basically you need to understand what to forecast and when to forecast and when to end your forecast and what is the forecasting frequency. Okay, so these are the so-called forecasting tasks. We must be clear, right? When you perform a forecasting task, you must be clear about your tasks. Okay. All right, so let's perform a very seems straightforward activity, right? So name one possible time series forecasting example. Remember, it is we use time series, okay? Of course, you may have other quantitative data to use in your forecasting. Here we focus on time series forecasting, okay? For each of the following themes. For example, you want to forecast something which you are interested in about a Singapore society data. Okay, for example, the annual growth of Singapore population between 2025 to 2035. Okay, 10 years, right? Annual growth of population in Singapore. Okay, and or STI listed companies. I just mentioned one, right? Okay, so you can, yeah, you can share your examples. Okay, so we have uh, Samaran, right? You say HDB housing prices. Yes, you want to predict. For example, you want to predict the HDB house price from 2026 to 2030, right? In the next 5 years, right? So what is the HDB price index, right? Okay, the number of people vaccinated during the period from September to December in 2025. Fantastic, right? Lin En Chin, fantastic. Yeah, you want to predict how many people get vaccinated, right? Against the influenza during the period, right? Because from September to December 2025, you can see you are very clear about your subject to study and your studying your start of your forecast, your end of your forecast. Of course, we know this data is available now, right? Because it is 2026, right? However, suppose in 2025 January you want to predict, right? You want to forecast the number of people vaccinated. That will be a fantastic, forecasting project you can consider, right? Yeah, Joshua says COE prices. Yes, right, COE prices. And you can see maybe it will become lower, right, or decrease in 2026, right? You want to, for example, predict the COE prices price at the end of 2026. Okay, there will be a few times COE auctions, right? So those COE price may we want to we want to see maybe a decrease COE prices in 2026, right? GDP growth, yes. Singapore GDP growth. And actually, you can see now, due to this geopolitical tensions, right? It is not stable, right? Our ministers actually mentioned a few times, right? There could be negative impact to a Singapore economy, right? So the GDP growth rate may not be as forecasted or predicted in maybe early this year, right? So we may consider what could be the GDP growth in maybe the next 3 years, next 4 years. Okay. Yeah. Yeah. Population growth. Yes. Yeah. Forecasting Singapore's annual employment rate. Yes, from 2026 to 2035. Yes, indeed. Now we are in 2026. We want to predict. We want to forecast the annual employment rate, or maybe annual unemployment rate, right? From 2026 to 2035 in the next 10 years. To Sentosa, yes, you can consider. Yeah, you want to forecast. Yeah, because maybe every day, this growth of visitorship to Sentosa, maybe you can consider daily a number of visitors to Sentosa, or you want to say monthly, right? Monthly number of visitors to Sentosa in next year from 2026 January. Now we are in February, maybe from March to December, okay, or next February for a whole year, okay. Yes, indeed, yeah, we have a various any when you consider the forecasting task, remember those four characteristics or four key components. Basically, you need to have a clear, subject to study. So, what is your subject to forecast, right? And because we are applying the time series forecasting, and so you need to have a clear start point of your forecasting, the end point of your forecasting, right? And then the frequency of your forecasting, whether it is daily, weekly, monthly, quarterly, or yearly, right? Okay. So STI listed companies, yes, you can see company quarterly revenue from 2026 to 2028. For example, a DBS, right? You want to forecast the quarterly revenue of DBS from 2026 to 2028. Yes. Now I think DBS released the fourth quarter revenue of 2025 and the yearly revenue in 2025. I think a few weeks ago, you can see DBS share price decreases, right? Because the revenue or the profit uh, cannot match with expectations of the market, right? So the share price decreases. Okay, now you want to predict, you want to forecast DBS quarterly revenue in 2026, in 2029, 2027, 2028, right? Yes. So this one of the applications of the time series, right? Especially those listed companies, they release, right? They release their quarterly uh, financial and operational performance in a quarterly basis, right? Sometimes some companies, they also release, for example, monthly based data. For example, the number of delivery in terms of maybe some car producer, for example, Tesla, the monthly delivery of their certain EV models, right? So we can apply the time series, right, to do the forecasting. Okay. So you can see we have various areas that we can apply time series forecasting, right? And because they are time series, okay, because you later we will explain what is the time series, okay. Very good. Yeah, this is actually one of the participation I want. So please do contribute to the discussion, to the activities, either in the chat box. Maybe later you want to share your screen to demonstrate the steps using R. Okay, that will be fantastic. Okay. All right. Yeah. So now time series. So we mentioned we want to focus on the forecasting based on time series. Okay, time series of the subject you are interested in. Okay. So what is a time series? Basically, you can see it's very simple and very straightforward, right? Time series means you must have at least two uh, attributes or two ingredients, right, in your data. First is the time, right? The time. This can be maybe monthly, right? Monthly, each month or each week, each day, even each minute, each second, okay, for high frequency data. Okay, uh, the data of regarding to measure your subject of interest, for example, the number of visits, right? So you can see there are two columns of a time series. So the time and the variable, okay, the variable to indicate the subject of interest. Here, number of visits, right, in Jan, February up to December, maybe the whole year, right? This 12 months data, okay? And the number of visitors, okay, in each month, actually remember, it is a random variable, okay? It's a random variable actually. But once you have this time series, for example, the 12 months number of visitors in the past 12 months in 2025. So actually it's a realization, right, of a sequence of random variable. For example, in January, the number of visits, maybe you can use x1 is a random variable, right? And now 34 is a realization of this random variable, right? And in February, you use x2 to denote the number of visitors in February. Okay, then 29 is the realization of this random variable, right? So basically you can see you have a data. This data actually is a realization of a sequence of random variables, okay? Okay, so yeah, the observations of subjects throughout a time range. Okay, here this maybe a whole year from January to December, 12 months. And one subject studied. And here we focus on this is a univariate time series. So you can see we only have one variable. This is the number of visitors. Okay, this is actually the subject of interest or the subject you want to study. Okay, you want to forecast. So this is a univariate time series. Maybe you have another column. This may be multi-variate time series. Number of visitors, maybe sales, for example, right? In, this maybe these two columns, okay, two columns of data, and besides this column of time, okay. So this maybe will be a multi-variate time series, okay. So in this course, from seminar 1 to seminar 6, we will focus on the univariate time series, okay. So we will only have one variable or one subject of interest to study. Correlated observation. So what does this mean? This means, for example, the number of visitors in each month, for example, in January and February, they are correlated. If they are not correlated or they are independent, so you will not have any information, right? You can extract from the past data, right? If in each month the number of visitors are totally independent, okay, so you cannot use that data to predict anything because they are not correlated, right? So in a time series, basically we focus on the time series where the observations are correlated uh, from different periods. Okay, if they are independent, so later we say once you, for example, once you have a time series where you test that it's a white noise process. That means you will have nothing to extract from the time series. Okay. So we need the observations correlation among the observations so that we can use the information, extract the information, and then predict the future. And time series, we need to have a constant time gaps. You can see the constant time gap. If, for example, you January and you don't have February, then this will be a problem, right? Because if from January to March, then April, and maybe, for example, you have no data in July, then this will be a problem when you apply time series analysis, right? So we need to ensure the time gap are constant. For example, this is monthly based, right? January to February, right? February to March, and each month you will have data. Or from weekly, if you have a weekly data, right? And then the time gap will be 1 week, okay? And sometimes you may have, later we will discuss how to resolve the issues with missing data or resolve the issues with maybe outliers, okay? So constant time gap between each pair of observations, okay? So the time gap must be constant between each pair. Sequential observations. And so we will present the data according to the date where the data is collected, right? So these are sequential data, okay, or observation must be sequentially presented. Okay, you cannot put maybe February before January and then come with March, then it will be weird, right? And then the time when you apply the time series tools or frameworks, you may have wrong result, wrong conclusion. Okay, so we must ensure the observations are sequentially listed or presented, right, in your when you prepare the data for forecasting. All right, so these are the characteristics of a time series. Now let's look at the time series forecasting process. Okay, so basically, because we focus on the quantitative, right, quantitative forecasting, so we need to have data. So basically, so data is your input. Now in today's world, you can see data actually is very, very valuable and important to any organization because we want to make data-based decisions. Right? We want to make informed decisions based on data. Okay, so data has become, you can see, strategic assets, right? Strategic assets to any organization. Okay, so we need to have data, and then you may have raw data collected by maybe various tools. For example, in the current digital economy, you have data from various sources, right? So you have different various digital technologies to collect data, right? And some data cannot be directly applied or analyzed using statistic frameworks or tools. So you need to prepare data, clean data, right, and transform the data in a required format, right? So you need to prepare data, right? And time series data, because in this course we will use time series frameworks and tools to do forecasting, right? So we want to ensure that data is converted into a time series format, okay, time series data. And then with time series data, and we apply various models, time series analysis frameworks and tools, right, to analyze the data, to extract the information from historical data, right? And then we build a model. And sometimes, though we need to find maybe the best model, the best model. And in statistics, okay, statistics is not like mathematics, right? Mathematics is rigorous. We know that, right? You have a rigorous process, for example, to prove some series, to prove some theorem, propositions, lemmas, right? You have a very rigorous derivation process. But in statistics, because you are playing with data, sometimes the model, okay, to find a best model is, from my perspective, it's art. It's an art, okay. So you may have various models to fit the data, right? To extract the information from the data, and so which model is is the most appropriate ones, right? So sometimes it's art. Sometimes it's not easy actually. Okay, so because you have many models can be applied, right, to the same time series data. Okay, so we fit the model and find the maybe the most appropriate model, or elegant, simple, or with less of with fewer parameters, right? Easy to interpret, right? These kind of models. And then we use the model to do forecast, right? And we forecast the future. Okay. So these are the general process of time series forecasting. Okay. Later, once we understand, so for example, we have different types of time series. We may have stationary time series. We may have non-stationary time series. Right. For stationary time series, we can fit the AMA models, right? And then for the AMA model, we need to test the stationarity. We need to test whether the final outcome is a white noise or not. And then we need to select the parameters in the model. And then we need to estimate the parameters in the model. And then we also need to optimize the model, right? Select the most appropriate models, right? Through maybe comparison of various models, okay? So this is a general process, right? Data input, we need to collect data, and we need to prepare the data, right? And then transform the data into time series and fit the data, fit the model based on the time series, and estimate the model parameters, evaluate the model, and then use the selected model to do the forecasting, right? So this is a general process of time series. All right, so let's look at this discussed question, okay? Let's look at the background. So a customer satisfaction survey was conducted by the management of a shopping mall for 14 days, okay? You look at this, you say, wow, they have a time period, 14 days, okay? So we can interpret that the survey was conducted on a daily basis for 14 days. Okay, every day they conduct the customer survey, satisfaction survey, and then conduct the survey for 14 days, and then collect the data. So they collected 3487 questionnaires. Okay, so this is the total number of questionnaires were collected over the 14 days. Okay. And so they classed the customers into two groups, satisfied and dissatisfied customers. Okay, that's okay. This is the background, right? The analyst needs 7 days. Okay, it's another time period. Okay, 7 days to complete the evaluation. Because you look at the questionnaire, you want to classify whether the customer is satisfied or dissatisfied based on the questionnaire, right? Okay, so the analyst needs 7 days to do the maybe data preparation or cleaning or classification, right? And the count of satisfied customers evaluated at the end of each day. So total is 7 days because the analyst use 7 days to complete the 3487 questionnaires, right? Is displayed now the number of satisfied customers, okay, displayed in this chart. Now let's discuss whether this is a time series or not, okay? And yeah, you can input your answer, share your perspective in the chat box, okay? Okay, Yong Yuan En says it should be based on the day the survey was conducted, not the evaluation. So this chart actually says this is the number of days because the analyst use 7 days, right? Use 7 days to complete the classification of the customers of the 3487 customers, right, into two groups. Either a customer is satisfied, a customer or dissatisfied customer. Okay, so this should be okay, right? Because this chart display the number of satisfied customers per day, and then because the analyst use 7 days to complete everything, complete this evaluation, 3487 questionnaire. Okay, so the data, this is a chart of the data set. Now let's discuss whether this is a time series or not. Okay, can you share your perspective? Are you all clear about this example? Okay, we have a few response. Let's look at the response. If we are Alma Williams, right? You say if we are looking at daily satisfaction rate, then it can be considered a time series. Yes, to be specific, if you say, for example, the number of customers, right, visit the shopping mall, right? the number of customers visiting a shopping mall or daily numbers of customers visiting a shopping mall itself is a time series. Correct. Okay. And then you say the number of satisfied customers per day or daily for those visitors visiting the shopping mall is a time series. Indeed, yes, correct. Right? I think okay. Jia says it's a time series. The data points are plotted in chronologic order over the 7 days of evaluation. Okay, if you look at the plot, right? Look at this chart. Yes, the data are plotted across knowledge according to the sequence, right? From day 1, day 2, day 3, up to day 7, right? And then the analysts complete that. And if you look at this, it seems like a time series, but you need to consider, right? Here, this refers to the satisfied customers, and the satisfied customers comes from the number of questionnaires processed by the analyst in each day, right? So there must be something wrong, okay? So we will have maybe a conclusion, okay? Lin Yi Qin says this is a time period. Oh, I guess you say this is a time series, right? And Yong Yuan En says not a time series. Okay, yeah, at least we have two opinions, right? One opinion is this is a time series. Okay, if we look at the chart, it seems like a time series. And but if you read the background, you may have concerns. Maybe it's not a time series. Okay, at least we have two different opinions. Okay, Vera says it is a time series because it's subject and a time range. Okay, so later we will discuss. Okay, you say, oh no, it's not a time series because cumulative. No, cumulative is okay. When you present a data time series, if the vertical axis is cumulative, for example, let's go back. Here, the number of if it changes to the cumulative number of visitors, that's okay, right? For example, you have another column, the cumulative visitors, right? 34 in January, and then in February you will have 34 plus 29 will be 63, right? That's okay. You present the time series in this way, that's okay. You just do a one-step difference. You will get the number of visitors per month in that month, right? That's okay, right? Whether actually it's not a critical point here, okay? Okay. Chuang King Wen said it's like the count of satisfied customer over the survey period while it measures across time. It doesn't have any useful meaning. Yes, actually it's not meaningful, right? So if you analyze this data, what is the point, right? What is the meaning or what is the information you can extract, right? Actually, it's not about the number of satisfied customers. You are dealing with the productivity of this analyst, right? So if the for example, analyst evaluate more questionnaires on day 1, and you may have maybe a more number of satisfied customers on day 1, right? So actually, so this is why we will say may not be a time series later, okay? Samira says time series, okay, it's one opinion, right? And Nicholas, not a time series, okay. Seems like the satisfied customer should be on a daily basis for the 14 days. Actually, anyway, we need to look at the chart, okay? Because they present the data in the chart in the left panel, okay. Okay, and as long as I can see that. Okay, let's look at the Liu K. I don't think it should be treated as a time series, as the chart seems to show cumulative. Okay, it's not. It's actually just the way you present data. Okay, actually, it's not a critical point to evaluate whether this is a time series or not. Okay. Okay. Anyway, I look at the answer. Some says it's a time series. Some says not a time series. Right. Okay. Okay, so let's look at this time series I mentioned, right? So this time series presents the number of satisfied customers uh, from day 1 to day 7 because the analyst used 7 days to complete the total 3487 questionnaire, right? Okay. Remember what I mentioned about a time series, okay? So you have a time, okay? Clearly, okay, we have time, 7 days. And in each time, you have an observation of the subject you are interested in, right? So this is 2 columns, right? 2 columns, okay? Time 1, maybe day 1, day 2, up to time 7, day 7, okay? And okay, you do a difference. You can see maybe, for example, like maybe 500. Okay, okay. That one you find there are 500 satisfied customers, and they maybe that one seems sorry, they two 500 minus something, right? So that one maybe, let's say maybe 50. Okay, 50. Okay, 50 satisfied customer, and they do the cumulative with 500. Maybe they do you find there are 450, right? Satisfied customer. Okay, I just use these 2 days. Now let's look at this 50 and 450. This 50 says the analyst in day 1 completed maybe a certain number of questionnaire, and then he find there are 50 satisfied customers. So you can see it's not a random variable. Number of satisfied customers in day 1. Actually, it's a number depends on how many questionnaire processed by the analyst on day 1. Right? If the analyst process more, for example, 1,000, and if the proportion of satisfied customer on average in a questionnaire, right, is maybe some number, so definitely you will have a higher number of satisfied customers recorded in day 1, right, and so on and so forth. So you can see, so this it's not this observation number of satisfied customer actually depends on the productivity or number of questionnaire processed by the analyst, right? This is the first thing you need to understand, right? So it's not a purely random variable that happened, for example, in day 1 or day 2, okay? And second, the total, you can see the total questionnaire is fixed. That means over the 7 days, the number of questionnaire processed by the analyst is fixed. Okay, is fixed. And then if the proportion, okay, say the proportion of satisfied customers who visit the shopping mall is counts, for example, 0.5. Maybe 50% of the customers are satisfied. So actually the number of satisfied customers are fixed over these 7 days, right? Because the total number, you can see total number of customers is 3487. So you can see you are not clear. So this number of satisfied customers, right? The subject actually is not clearly defined. It's not clearly defined. Okay. So what do you mean by, if you say, I think some of you mentioned, if you say the number of satisfied customers, daily customers, right, visit the shopping mall, yes, it's then if we record the number, those numbers according to each day, then it's a time series. Now, this time series actually, you can see first is a fixed sample size, is fixed over 7 days. And then this number of satisfied customers per day depends on the process, maybe capability or productivity of the analyst, right? So actually, what you are doing here, you record the number of satisfied customer per day is meaningless, right? So actually, you want to actually measure the productivity of the analyst, okay? So it's not so we will say it's not a time series, okay? I highlight just now. So this, for example, the number of visitors in a time period. In a time series, this should be a random variable. And now this is just a realization of this random variable. Okay, and then this whole time series is one realization of all the random variables. Okay, so now we will say it's not a time series. Okay, so are you all clear? Do you have any questions? Okay, great. So remember, so for time series, so technically we say, right, this T, or we use xt to denote the subject of interest. And this should be a random variable in each T. Okay, and then a time series, just a realization of a series of random variables. Now, if you say each day the number of satisfied customer is a random variable, actually it's wrong. It's not a random variable because it depends on the analyst productivity, and the total questionnaire is fixed, right? So it's not a random variable actually. Okay, depends on the analyst productivity, the number of questionnaire processed in each day, okay, over the 7 days. All right, so it's not a time series, okay. Okay, let's do a quick summary. Okay, do a quick summary. So we have two main categories of forecasting methods. Qualitative, you don't use any data. Your forecast will be based on your maybe subjective knowledge, right? It's very subjective, right? Depending on your opinion, your perspective, even your maybe your emotion sometimes. Okay, if you are happy, you want to see maybe future is brighter, right? If you are not happy today, maybe you say future is not bright, right? So it's purely subjective, right? The qualitative, but in reality, in practice, right, you need to get the experts opinions or forecast, and then you do a synthesize because they have a certain expertise or background, right? They have more knowledge of a certain event or certain subject. Okay, and quantitative means you need to use data, right? You need to rely on the historical data information, right, to understand the underlying process, to understand the underlying maybe mechanisms, right, which govern the time series. Okay, so we need to use various quantitative methods, frameworks, right, data analytic tools, right, to extract the information from historical data. And then with the information, with the knowledge, right, from data you get knowledge. With the knowledge, right, you can predict future. Okay, there are broad areas of forecasting in business areas, right? In operations, in risk management, in financial market, right? In economy, in society, and in maybe various ways, okay? In marketing, various ways, okay? Univariate time series, right? We focus on the new univariate time series. There is only one um, a subject of interest, right? And it's one measure of the subject of interest. You collect data on that measure, and those is the collection of equally frequent sequential observations. Okay, so these are very important. You can see equally means the gap between each pair of the observations, the time gap must be the same. Okay, and sequentially present the data in according to the sequence, according chronologically. Okay, in a specific time range. Okay, time series data contains a data column and a time variable column. So basically two columns, right? The time where the data is collected and the realization of this data, or you can say in each period. Okay, you xt or use yt or zt, right, to denote the observations. We need to fit models with the data, and do forecasting. Only you have a proper data preparation, right? You need to convert the data into time series format, and then you can apply time series frameworks and tools to conduct the analysis and forecasting. Okay. Vera, yes, it's not a time series data. Yeah, it's not a random, right? Because it depends on the productivity of the analyst, right? This is not correlated, purely correlated here. You can see here the number of satisfied customers in day one, number of satisfied customers in day two, you do a difference. Actually depends on how many questionnaire processed by the analyst. Okay, they have nothing. The correlation between the two numbers actually meaningless, right? If the analyst process many questionnaires on day two, maybe just a few questionnaires on day one, so what is the meaning of this correlation? Nothing, right? It's meaningless. Okay, yeah. All right. Okay, let's see how many pages we are left. Maybe we should do introduction of R. Okay, so let's have uh 10 minutes break. Okay, 10 minutes break. And I hope, okay, I hope you have installed successfully of R and Anaconda and Jupyter Notebook, or even RStudio. Okay, this software in your laptop or desktop, because later in the next half of the seminar one, we will perform the demonstration of R. Okay, and it's a very powerful computing software and tools, especially very helpful for time series analysis. Okay, so I hope you have followed. Let me show the installation. Okay, installation by instructions by Dr. Wu. Okay, installation, how to install. Okay, if you have problems, okay, do let me know. Maybe I can help resolve your installation issue. Okay, and yeah, let me open this. We install R Studio. I think this is an Anaconda installation. Okay. Yeah, Anaconda installation with R. I'm using MacBook actually. Okay, I'm using MacBook. Oh yes. You can use any other. Okay. Those coding environment. As long as you can use R, right? Google Colab. Okay. Actually, I tried. I tried. I'm comfortable with RStudio and this Jupyter Notebook. Okay. Yes. Any coding environment you want to use, as long as you can use R. Okay. So that's okay. Yeah, Anaconda, right? You download the Anaconda, and you download the Windows version or Mac version, and then make sure if you use a MacBook, the latest version, for example, the chips with M1, M2, or M4, you use Apple Silicon, this graphic installer, okay? And if you use Intel chips, right? Intel chips, you need to download other versions of the installation package. Okay, no worries. Okay, PR, P, PR key, right? Junxian. Okay, as long as you can use R. Okay, and as long as the output from your result or from your program and from your code is the same as we have. Okay, that should be okay. Okay, yeah. And download, okay, yeah, you especially for MacBook users, okay, for MacBook users, you need to pay attention to how to link, how to install R, right? And once you install Anaconda in your laptop, okay, install R in Anaconda, right? Anaconda, you can see your launch this Anaconda prompt, and you can copy, right? You can copy uh, this into your prompt and then execute, and so you can install R. And now the version of R is 4.5.2. Okay. Okay, so then you can ensure that when you launch Anaconda, you choose the environment which is R, okay? And then you can launch a Jupyter notebook, okay? And the Jupyter notebook, you can see this with extensions IPYNB, right? Extensions of the Jupyter notebook, okay? Yeah. And whenever you run the code, you select kernel, which is R. Okay, yeah. So later we will demonstrate the steps. So let's have a 10-minute break. Please come back at 8:30. Okay, 8:30. All right. We are back. Yip, currently, yes. Any computing software environment you want to use, as long as you are using R, because I mentioned in this for this course we will use the package developed by our course leader, the TS forecast in R. So as long as you can use R, you can use that package to conduct the time series analysis. That should be okay. No matter whether you use Anaconda, Jupyter Notebook, or you use RStudio, or use Google Colab, anything, okay, as long as you can use R. Okay, yeah. All right, so we will in this part we will demonstrate, okay, because honestly, I'm also new to R. I use MATLAB and eViews before to do time series analysis, and in my research, okay, I use MATLAB. Uh, um, so we will use R for this course. So R is just a simple introduction, right? The programming language for statistic, computing, and graphics. So very powerful, and most importantly, it's free, right? You don't need to pay any license fee. Okay, it's free, and the packages are regularly updated by various authors and verified, right, by various authors. And best, for example, if someone has some new statistic methods, develop new statistical methods or test, and then there will be our package available, right? You can use that, maybe the latest statistic analysis tools and methods to conduct your analysis. So it's very powerful. Okay. Anyway, so as long as you can use R, whether you are using RStudio, you use Anaconda Jupyter Notebook, or Google Colab, everything, right? As long as I can be used and the TS forecast package can be utilized, then it's okay. Okay. So there are a few different. So the package, okay, package refers to maybe a collection of functions, R functions, which developed by different authors or different developers, right? So to perform certain statistic analysis. For example, in terms of time series analysis, there are a few actually, a few packages developed by, for example, the authors of certain books. If you write a book on time series analysis, and you might develop maybe many R functions which can be used in your book, then you combine them together as a package, right? So here you can see we have a few packages which can be used to perform statistical analysis for time series. For example, we have T series, right? This package includes functions for time series analysis and computational finance, right? So those people in the finance area who doing finance research may use this package very often. TSA, you can see this package has been developed by the authors for the book, right? Time series analysis with application in R. Okay, so this R package developed by these two authors. Forecast, right, is another package, right, which can be used to perform time series analysis. TS Studio. So this actually is very powerful. You can see this provides interactive visualization of time series objects and a utility function for automation time series forecasting. So this is very powerful. And for this course, we will use this TS forecast package, okay, developed by our course leader, okay. And this package actually includes very many functions which we can use in time series analysis, okay. So TS forecast If you use RStudio, okay, you can maybe let me open RStudio. Sometimes you need to, if you don't have the package TS forecast, you need to install, okay, install packages, okay. Do I have? Okay, this RStudio. Okay, this is the RStudio, and you need to install all packages, right? Install package TS forecast. Yeah, you can see it's not the file size is quite small, right? And then this you can download. Actually, you can check you can use Google to search TS forecast R package. Then you can find the documentation for this package developed by Dr. Wu. Okay, then you need to install this package. Okay, if you use RStudio or if you don't have, and whenever you use a package, for example, some functions may be specific in some packages. You need to use, for example, library, right? Library, some package name. Okay, TS forecast. Okay, so this is RStudio. RStudio. I'm also using RStudio. Okay. So let me go back to the slides. Okay. So yeah, these various R packages which can be used to perform time series analysis. Sometimes, okay, sometimes the functions in different packages may have some, you might incur some issues, but don't worry. Okay, we will focus on this time series TS forecast package. Use this package. Okay, R. So let me go to the Anaconda. Okay, so once you install Anaconda, right? Anaconda, then you can let me go to my browser. My browser, I open it. Okay. Okay, so disappear. Chrome. Okay, so let me close this. I installed Anaconda in my laptop, so I click Anaconda. So this is let me share the screen. Yeah, here. Oh, okay. So this is the Anaconda navigator, right? Once you install Anaconda successfully in your laptop, okay. So I launch Jupyter notebook or Jupyter lab. Actually, they are similar. The UI are very similar. Okay. So I launched a Jupyter notebook. Okay. Can you view my screen? Yeah, now you should be able to view my screen. Can you view my screen? Okay, great. Yeah. Okay. So once you launch the Anaconda, all right, navigator, then you click launch those Jupyter notebook. Okay, Jupyter notebook. Okay. So this files actually I put a file in my desktop here. I put this course, the materials in a folder in my desktop. Okay. Those are all the files I have. Okay. Then let's create a new. Okay. Here in the top right, okay, top right corner, you can see new, right? New or upload something. So let's create a new R, okay? New R. Okay, so you can see this is a new Jupyter notebook you will create, right? You will create in your folder. For example, you go to the home. This is the untitled. Okay, you want to change your the name of this Jupyter notebook. Okay, you can change the name. For example, let's say seminar one uh, demonstration demo. Okay, seminar one demo. Okay, yeah. So here, ensure in the right corner, you can see there is the kernel you need to use. Here you can see R. You can see R, Python 3, or no kernel. We will use R, okay? Anyway, ensure this R is selected because we will use R to do the analysis. So R is very actually straightforward to use. I believe you if you didn't use R before, you can spend some time, right? Some to go through how to use R. Very simple actually. Okay, not sophisticated. For example, we want to uh, do something. For example, you want to create, you want to do some simple computation, 2 plus 3, okay, 2 plus 3. And then here for Mac, okay, Mac, some settings you can change, for example, some theme, right? Theme, whether you want to use light or dark with contrast, right? So these are the settings for this. And you can also view, right? You go to view and you want to change something or select some options, okay? And here, some of you, if you use Windows, you should be able to highlight the function calls in R in different color. But here in my MacBook, unfortunately, I cannot highlight the functions, okay? And yeah, some yeah, you can go through these various options in different tabs, right? To set the maybe the most comfortable UI interface. Okay, for example, you want to calculate this simple 2 plus 3, and you just in my book I press command and return, then you will get this. Okay, sometimes you can change whether you just press return and do the run the code. Okay, and then you can, for example, you want to create a new column for code. Here you can see code, markdown, and raw. Okay, code means something which can be executable. Okay, for example, A, and in the note in the seminar slides. So our course leader use this assign this less and plus like a minus sign, right? Assign notation, right? For A equals 3, okay? This means you assign 3 to A. A is the variable you define, okay? And if you want to see A, and you just type A, and you will see A equal to 3. Or you want to say use a print, okay? Print A. Then you will see A equal to 3, okay? All right, so you can see, actually I prefer use equal sign. For example, A equals 4, okay? And print A, okay? I want to use equal sign, sometimes simple. You don't need to type this less sign and this like arrow, right? So I use an equal sign to assign a number to a variable, okay? And you can also, for example, let's say you define another, for example, B. Okay, B equals maybe you want to assign something hello world. Okay, hello world. Okay, then you want to see B. You type B and then you execute this. You can use this run this cell and advance the same thing, or you can use print B. Okay, print B. Okay, hello world. Okay, this is assign this hello world. This is a string to this variable. Okay. All right, so this is very straightforward, actually, very easy to use. And um, let's see. Okay, this is a variable. Okay, you define a variable A, B, or C. For example, here we define A equals 4. Then if you want to, for example, I create a new code cell here, A plus 2, A plus maybe A plus 3, because you already define A equals 4 here, right? You assign 4 to A is a variable. Now, if A plus 3, then 4 has been stored in your memory. Then A plus 4 should be equal to 7, right? So you can just execute it. A plus 3 will be equal to 7 because A equals to 4, okay? All right, what else? So this is a variable, right? You can use this sign, assign, right? This assign operator, this less plus this minus sign, okay? And then assign a number to a variable. Or if you prefer, you can use equal, okay? Equal to assign some value to your variable, okay? Or to your array, to your matrix, or even to your data frame. Okay. So I prefer use equal sign. Okay. So this is a variable. Okay, variable. Let's say arrays. Okay, arrays include, so like a vector, right? Like a vector. For example, we want to create an array. For example, in the notes we say my array, right? My array. Okay, when you define variable in R, uh, so make sure there are the variable, the name of the variable, of the name of your array, the name of your matrix, the name of your data frame, or anything you define. There are no space. Either you use dash or you use dot. Okay, and actually make sure the name of the variable, the things you define is easy to recognize. Because later, for example, you check your code, you need to know what is that, right? So you make sure the name are easy to recognize. Okay, my array equals, for example, I want to assign a few numbers as a vector. Okay, for example, 1 to 6, right? So my array equals it's a column vector, and from 1 contains the numbers from 1 to 6. Okay. If you print my dot array, right, you can see it is 1, 2, 3, 4, 5, 6. Right. This is an array with 6 elements. Okay. Okay. This is array. We can also, for example, matrix. Okay, we assign a few we create a matrix with my matrix. Okay, matrix, and we will use a function in R called matrix. Okay, matrix. Then because a matrix have rows and columns, right? For example, this can be we want to create a maybe 2 times 3 matrix, maybe number of rows is 2 and the number of columns is 3. So for example, C1 to 6 means this is an array with 6 elements from 1 to 6. So in total, we have 6 elements, right? And then we want to convert this to 2 times 3 matrix. Okay, so then you can my matrix. Okay, my matrix. So it's a matrix. Okay, so you can see this matrix contains 1, 2, 3, 4, 5, 6 elements, right, in this matrix. And I always create this column by column. You can see because C1 to 6 is an array, contains 6 elements from 1 to 6. And then rearrange this array into a matrix into a 2 times 3. So 1, 2, you can see 1, 2, first column, then second column, 3, 4, and third column, 5, 6. Right? So this is my matrix. So you can use this matrix function to create a matrix. Okay. You can also use print my matrix. Okay. Print my matrix. Okay. Print my matrix. You can see very clear. You will see this is a 2 times 3 matrix, 2 rows and 3 columns. And then I create this matrix from column by column. The first column 1, 2, then the second column 3, 4, then third column 5, 6. Okay. Okay, so if we want to see, for example, I want to see this my array. Okay, my array. I created something below. I want to see a specific value in a certain position of my array. Right? You will use this bracket operator. For example, my dot array, and I want to see uh the first row and from third to 3 column. Or for example, my first row, my first elements in my array. That's good enough, right? Then this will be 1, right? And if you want to see maybe my third column, third elements in my array, it should be 3. Okay, so should be 3. So you use the bracket operator to see the elements in your array. And if we want to see, for example, the elements in your matrix, okay, in your matrix, for example, here, my matrix, right? My matrix, we have 2 rows and 3 columns. Okay, so let's see, I created this below. I want to see my matrix. For example, I want to see the first row and the uh, 2 to 3 column. So basically, first row will be this row, 1, 3, 5, right? The first row. And 2 to 3 column should be 3 and 5. So this should be give me 3 and 5 from the first row, column 2 and column 3. Okay. Here you can see 3, 5. Okay, if you want to define this as maybe your C, right? And then you want to print C, then this C will be an array contains 2 elements, 3 and 5. Okay, right? This is the array contains yeah. All right, so this is your access the elements in array or in columns. You use this bracket operator. Okay, bracket operator. Okay, so let's see another types of data, which is list, right? In R list. Here, for example, as shown in the seminar slides, we create a list called employees. Okay, then you use the list function. Okay, list function. List means you contains the same, maybe a few different elements in a data structure, right? For example, this can be array, maybe another can be a matrix, something. Okay. For example, we consider this. Let me do this way. I create three arrays. First name, right? I use C function, right? So this contains three names, right? Three names. We use this double quotation to denote this strings. And what is this? Ben. And what is this? Charles, right? Charlie. Okay, Charlie. So this is a first array. Okay, and then maybe the age is another array. 32, 27, and 39. Okay. Okay, so if you want to put different things in the same column, you use this colon, right? So age, then position, right? Position equals what is this? HR head, right? HR head. What's this? This CEO. CEO. Okay. And sales manager, right? Manager. Okay. So these are the three arrays I created. So you can put it at put them together. You can see this array contains strings, and this array age contains uh, numerical values, right? And this position also contains strings. Okay, so let's put them together as a list. Employees, okay, equals a list. Then first name and age and position. Okay, so I will create this uh, list, and then I want to see this list. Okay, you can use print or you directly just type the name. Okay, and then you execute this code. You can see this is the list. Or if you want to use print, right? Print employees is a list. Okay, you can see the list, right, contains three things, right? The first is the list, first array, the second array, and the third array. Okay, so here because uh, we if we put this way, you will see employees equals to list. Let's copy. Okay, copy each one. For example, first name. Okay, into the list, right? Okay, then you will have the name of each element in the list, the age, the age, and the position. Okay, position. Okay, so if you use this way, let's look at the list employees. You can see the list, the first element, there is a name of the elements, the first name, because you define the first name, right? And then the age, the second, right? And the third position. Now, if I want to see my the first element in this list, okay, so you can uh, add a new code. Okay, for example, I want to see employees first names. Okay, so you use this $sign, okay, first name. And then you will see there are three, okay, three elements. Okay, you want to maybe print, will be print this, and then you will see Ann, Ben, and Charlie, okay. Okay, so this is a list. So you will use this $sign to access the elements in the list. Okay, the $sign. Later you will see we will also use the $sign to access the columns in a data frame. Okay, in a data frame. Okay, so let's because employees is a list, right? List contains different elements. The elements may have different types. For example, the first this employee, the first name, the element actually first elements, the first name actually are strings. The age are numerical values, right? Positions are also strings, okay? So we want to convert this as a data frame, okay? Data frame will look like, the data structure in Excel, okay? So we convert the employees as a data frame. So data frame, this is an R function, convert the in basic R. And actually, if you use other packages, for example, tidyverse, and it will be a table. Okay. So here in basic R, this is called the data frame. Okay, data frame, we will convert employees, the list, okay, which is a data structure, as a data frame. Okay. So let's look at these employees now. Okay. Now you can see this will present the data or arrange the data like Excel, right? Here you can see first name is the column, first column, second column is age, right? The third column is position, right? And I want to, for example, see the first column, employee, or second column, maybe employee, right? And then because the name of the second column is age, so I use employee and age. So this will give me the output will be the values in this column age. Okay. Okay. So if you directly enter or execute this code, or if you want to use print, okay, if you want to use print, okay, then you will see this is the value of this column. Okay. All right, so you can see we have a variable, right? We have variable, we can define a variable, and this variable can contain any types of data. For example, either a string, either a numerical value, or called a double format, or either a data format. Later, we will need, for time series, we need to convert the date into a date format. Okay. All right, so now let's see, we have array, we have list, we have a data frame. So these are the basic structures in R in terms of how to store the data. Okay. Okay, so let's look, this is the basic thing, right? So let's look at how to import data from external files. Or if your data are in external files, so we need to import data into R, right? So for example, here, let's look at, let me open, okay. So we actually have data in CSV format, right? CSV format. So let me open which data? Arrivals. Okay, arrivals. Okay. Arrivals, I open with Excel. Okay. Okay, so you can see this is the arrivals Excel. Okay, I open the arrival.csv data in CSV format. So CSV format I use Excel to open it. You can see there are a few columns. Date, total arrivals, Southeast Asia, Northeast Asia, South Asia, something, right? And some of the data are empty. Cells are empty. For example, there are no data here, right? These are no data here. If you import this data into R, this will R will convert the empty cell into not a number NA, right? Okay, so this is the data actually, right? The CSV format, and I open it in using Excel. Okay. So now I want to import the CSV format data into Excel. Okay. Into Excel, let's look at, let me go back to my Chrome. Okay. So if you don't have, if you didn't install the TS forecast package, now you need to install packages, right? In your RStudio, same thing. Install this package is called TS forecast, okay? And you can execute that. This may take a few seconds to download and to here in your RStudio. I just demonstrate, right? You need to install you can see download the binary packages of this R package and then install in your R, right? Here, once you install, so we need to ensure that we use this package, right? Library, TS forecast. Okay, TS forecast. Okay, so we will use ensure. So for this course, because we use this package, so whenever you write any code, ensure that you use the library, right? Library TS forecast. So best we will use this package. Okay. Now we want to import data arrivals. So we denote the name of the data imported in R as arrivals. Okay, arrivals equal read.csv. So this is the R function. Okay, uh, read.csv, and then your file path of this your data set. Because I create this Jupyter notebook in the same folder, and the data also in my you can see the data is also here. Arrivals, right? Arrivals, yeah, here. Okay, this is arrivals. Okay, you can see arrivals.csv data. Okay, in the same folder, so I can directly go to here. So arrivals.csv. Okay, right? Arrivals.csv. Okay. So I need to import the CSV data into R, and if we want to see a few columns, a few rows of this imported data, so you can use this head function. Okay, so so this message actually you can ignore that. Okay, you can ignore that, and this means the TS forecast package and this some method by another package something, so you can ignore that. Okay, it's just maybe a warning node that not affect your output. Okay, so this actually you can see is imported data into R. Now I just look at the first six rows of this data set, right? This is a data frame in R. Okay, so we have this we can view 6 rows and 10 columns. So basically you can see there are 10 columns with column names, date, total arrivals, Southeast Asia, something. Okay, and if you want to see more, or if the whole data set, okay, so let's change this to print this arrivals. Okay, then you can see there will be all how many rows? 380. Okay, and you can see there are 380 rows. Okay, and you can see for example the number of rows of arrivals, number of columns of arrivals. Okay, so you have 380 rows and 10 columns of this data set, which is a data frame in R. Okay, yeah. All right, so we have, let's see what else we need to go through. Oh, let me go back to my, okay. Go back to what I need to go through here. Okay, so this is the R, right? We have basic usage of R. Variables, arrays, list, data frame, matrix, right? So for variable, array, and matrix, you use brackets to access the elements. And in list and data frame, you use this dollar sign operator, right, to access each column of the elements. Okay, and then you use read.csv function. Okay, to import data. Here you can see because this arrive in my working, the arrival.csv, this data set is in the same folder of the Jupyter Notebook or RStudio. If you use RStudio, the same working directory. Okay, so you can directly import the data into R. If they are not in the same folder, you need to put a full path of the data set. So, for example, maybe users something, right? Users uh, and maybe your name something if you use MacBook something, and then until this arrivals.csv, this full path of your file location. Okay, so now we import the data right into R. Okay, we import data into R, and we can use print function to see all the columns and rows of the data imported in R. Okay. Now, yeah, we can check the number of row and the number of columns of a data frame. Okay, use these two functions. Sometimes it's not useful, right? You don't use this. You don't need to. You just yeah. Maybe this is not useful. This just give you information. So how large is the data set? Okay, now we want to rename a column. You can see the second column, if you go back, the second column is total arrivals, right? And actually, this is the time series, right? And because the first column is the date, the second column is the subject of interest or the variable, univariate variable, right? And the total arrivals, but it's too long. Okay, you want to change this column name into total. So what you can do is you get the columns of arrivals. Okay, so let's, and then because it's in a second, okay, let's go back. Okay, so you can see the second column, total arrivals, it is too long, right? The name of that column is too long, so you want to make it concise as long as it is informative, right? So we use column names, arrivals. So arrivals is the name of your data frame, right? Arrivals, right? And then you get the column names, which will be array. Okay, and then the second the second elements in this array, which will be, if you type it, this will be total arrivals, right? Now you want to change it to a different name, okay? Maybe I make a short and concise name, Tutu, okay? So I change it to Tutu, okay? And then if you, now you look at the new variable names of arrivals, okay? You can see the second column has been changed to Tutu, right? Becomes short and concise, okay? And okay, so then what else? Okay, suppose you want to remove some, what is this? Okay, you want to replace, for example, the first um arrival total, this is a number 11814, right? You want to change to a different number. So of course you can use that bracket operator to change that, like this, right? You can, for example, you want to see arrivals and my column. Maybe I change another thing, okay? Maybe Southeast Asia, okay? So the third column actually, right? South Asia, and maybe the first one is a NA, not a number, means empty in Excel. So maybe first I want to have is and it's an integer, you can see. So maybe I put it as a one, okay? I I I I change this NA as one. That is a number, okay? And then you want to see, let's see the first row, okay? Arrivals, okay? Now you can see NI has been replaced by 1, okay? Now, and the type of this column has changed from integer to double, right? Because the numbers, numerical numbers, are stored in double format, okay? Okay, so you can see you can replace maybe a certain the value of a certain cells in your data frame, and as long as you can specify the position, right? Column, and then you will have an array, and then you use the bracket sign. First, you use the dollar sign to access each column, and then you use the bracket sign to access the elements in that array, right? Okay, so this is yeah, what you can do. The second thing is we want to remove a column, right? We use not equal sign, okay? Remove a column, okay? For example, we want to remove the third column, Southeast Asia. So arrivals, and here because we want to change that, so we use a bracket, means arrivals. This is a data frame, and if we use a comma, means all, and empty in the comma, it means all rows you will maintain or contain all rows, and then this column name of arrivals, right? So all the column name you, and not equal to something, not equal. For example, not equal to South East Asia, right? So means you, this will remove this Southeast Asia column. Okay, so let's see. Let's see. Now you can see there are no Southeast Asia column. So you only have 9 column, 380 rows and 9 column. Okay, so here I use column name. The seminar slides directly use names. That's the same thing. Okay, names. If you change it to names, let's rerun it again. The same thing, right? Okay. All right, so you can see this is you remove some column, okay? Okay, so next we want to convert, because we need to convert the data format into a time series format in R. Okay, so let's go back to the PowerPoint slide. All right, so you can see here you can see we have this, if you go back, here we have the first column, the name is date. The second column has been renamed to total, right? And you can see the type of date, the column is characters, right? It's not a date format. Okay, so it's not a time series. So we want to convert the date column into a date format. Okay, this is what we are going to do. We will use the as.date function. Okay, so we need to convert the time variable to date, okay, to be formatted as date. So we use this as date function, okay, to change the values of time variable to date format, okay. So here, let's look at, we want to change the first column, date, arrivals first column, which is date, right? Date into a date format. So we use as.date function, okay, and put a format, uh, uh, this format into date, months, and year, which is this month, actually like this. Okay, so let's go back. So this is very critical. Whenever you use a TS forecast package, when you perform the time series analysis, you need to ensure the data format. You need to convert the data into time series format. Okay. Okay, I add a new code cell. So we want to convert the first, so arrival date. So basically, I will change this column into the data from date format as date. Okay, as date. Okay, this is a capital D. Okay, and then arrivals date. Now it is in what is the format? It is in character format. Right? It's not accepted by R. And then format. Okay, format. This can be, for example, now you can see this character format, day, month, and year. Okay, so I need to ensure this double quotation marks. Okay, day, dash, month, dash, and percent, and y. This is year, month, and date format. Okay, and then you want to see these arrivals now. Okay, to see whether you have changed the character format of date column into a date format in R. Okay. Now, if you look at this, date, the type has changed to date, right? The date, the type has changed date. But you can see something is wrong, right? Here, why it becomes NA. This is because we use this dash. Actually, this used this sign. Okay, so we need to change this to this sign. Okay. Okay, I need to rerun. I need to rerun kernels. Stating kernels and clear output, and I rerun everything, all kernels. Okay. Okay. Hmm? This because I reinstall. Okay. It's gradually come out. Now you can see it is correct now, right? This is the date if you look at the original data frame, the first should be 1961, January the 1st, right? And then this convert to this format. Okay, so this is the as dot date function. So you need to convert, okay, convert the data into time series format. Okay, this is very critical step. Okay. All right, so in R actually there are a few different formats, right? You can see, right? Different format. You use percent sign plus this notation, right, to denote different formats. Okay. Okay, so now we change that date into date format. We need to convert the data into a time series. Okay, so become a TS object in R, time series object in R. So this will use this TS convert function. This is in that package, TS forecast package. Okay, so we use this TS convert function. Okay, and so this let me go back. Okay. So this is arrivals, the total. Okay, this is actually the subject of interest you are studying, right? You are studying. This is the time series data, and then the first is the time of the data. Okay, so we use TS convert function to convert that into a time series object in R. Okay. So the argument, the first is your time series, that data, right? You can use X, or if you can ignore X equals something. Arrivals and total, okay? Arrivals total. And time T equals arrivals total and date, okay? And you want to give a name of your time series. Okay, maybe for example you can say x dot name equals this double quotation sign arrivals. Okay, okay, right? So this is you use this TS convert function. Okay, TS convert function to convert this as a time series. And this x, this is the argument. This is the time series, and t the time. And sometimes you can ignore x equal. Okay, for example, you want to ignore x equal, t equal. That's okay, because the function will assign the first argument to x, the time series, and the second into the time. Okay. So in order to ensure everything is complete, let's follow what we have. Okay. Yeah. So you can print, you can maybe let's say okay, let's use print or head arrivals total. Now you will see this is a time series object. Okay. Now you can see this is a time series, and this is the year from month January to September, actually to December in below, right? October, November, December, because this cannot contain all the 12 columns. Okay, so this is arrivals total. So this is slightly different from what we have in the slides, right? In the slides, because in the slides you can see they have time series, start and end, start date, end date, and frequency. Okay, don't worry, because you can see some warning message earlier, and later we will be able to generate the same output, okay, as the one shown in the slides. So now, so this is a critical step. Okay, first you need to convert time into date format, And then second, you need to use TS convert to convert into a time series data object. Okay, so that you can use various time series models and tools to analyze the data. Okay. Okay, so now let's do an activity. Okay, do an activity. Let's import this uh, SP500 data. This is the CSV data, SP500 weekly .csv, right? This is the data, okay? And import this CSV data into R. And we need to convert the date variable to the format date in R. Okay, actually you can just mimic what we did just now, okay? And then convert the weekly average closing price, close. So the column name is close, right? Into a time series and call the series, this is a time series name, okay? So I give you, let's say 10 minutes, okay, 10 minutes to perform this activity. Then I will demonstrate the steps. Actually, if you can perform the same coding in the slides, you should be able to import the data and convert the variable format and convert that into a time series. All right. So I give you 10 minutes to do this activity. If you have any questions, you can let me know. All right. So far, do you have any questions in terms of the how to use R, the basic functions of R, and the TS forecast package, and various operations of R? Do you have any questions? Okay, that's good. Vera, that's good. Okay, yeah, please perform this activity. Okay, if you have no issues, please perform this activity. Let's import the data into R, convert the date into the R date format, and convert that column into a time series. So today is just an introduction of the basic operations of R, okay? And if you want to learn sophisticated and R programming, I recommend you to explore maybe various uh, materials from internet. And there are many. Actually, I learned this before I come to teach this course. Okay, so I actually now I find I quite powerful and also easy to use. Okay, so it's it's worthy to spend time to learn this programming language and use this language in your data analysis job or in your duty something. Okay. So you can just follow the steps in the slides, and you should also you can also download the Jupyter notebook for seminar one code, right? The code in seminar one, and then follow the steps. Nicholas, of course, if you want, I encourage you to share your, for example, steps, and so that maybe some of our classmates that didn't use R before and that can learn from you. And Nicholas, if you want to share your screen, once you finish this activity, that will be wonderful. Okay. Sure. Nicholas, if you want to share your screen, yes, I stop share. All right. So, okay. Yeah, Nicholas, you can share your screen and we can learn from you and whether we can, import the CSV data into R successfully and convert the date, okay, into a date format and all right. Okay. Let me.
Can you hear me?
Yes, yes, Nicholas, we can view your screen.
Yeah. So basically, do I need to explain or
Yes, you can. It's very
okay.
wonderful because it's a peer learning, right? We learn from each other. Okay. Yeah.
Okay. So I installed the package
Yes, very
over
good.
here. Then I loaded the library.
Yes.
So for reading the data frame I read the CSV over here.
Okay, very good. So
So
actually, this notebook is maybe in different folder of your data, right? The CSV data.
yes.
Okay,
So actually
all the same.
There's
Get the working
I
directory.
loaded
Yes.
in here lah. So this one actually access the parent folder
Okay, very good.
in data.
Okay,
So I just to check that I loaded it properly, I did a hit function.
okay, great.
So after that I converted to a date uh, over
Format.
here
Okay,
and I verified again lah.
okay, yes. So now
Mm.
the date column, the type is date. Okay.
Yes. So but for this I'm not very sure. Because in the question it was mentioned to save in a series called the S&P 500 weekly average.
Oh, I
So
see. Actually, you name your data series, the data frame. The name of the data frame in R as SP500 weekly, right?
yes,
Yeah, actually, is the question says we want to name the time series. For example, especially you plot the time series, and then if in the x axis something we were sure that this is the SP 500 weekly something, right? And
Mm-hmm.
yeah, actually you just change you name the data frame imported into R as SP 500 weekly, right?
I see.
Okay, no
Okay.
worries. Yeah, no worries. Yeah.
So I should rename this.
No. Let me show you. Okay.
Okay. So I
Okay.
stop my screen.
Okay. Very good. Actually, Nicholas, very good.
All
Yeah,
right.
you have a very active participation in seminar one. Okay.
Okay.
All right.
Thank you.
Yeah. Sure. Let me open my Jupyter. Okay. Let me open my share screen. My Chrome. Okay, so maybe I create I want to in the same folder I create a new notebook R. Okay, so here this activity. So I don't rename this. Okay, yeah, just maybe seminar one activity. Okay, seminar one activity. So yeah, I installed. So I just library. I use this TS forecast package. Okay. So we import SP 500. Okay, SP 500. So I read or CSV because the data set in the same folder, so I don't need to copy the full path. Okay, so SP 500 weekly.csv. Okay, so I import this 500 weekly CSV data. And then I want to add or verify this as P500. Okay. Yeah, so you can see it's a data frame. We have, you just view the first 6 rows. So we have 2 columns. The first column is date, which is the type is character. And the second column is close. This is actually the time series. And it's in the double format because it's numerical values. Okay. Okay, so we want to ensure that the date are in the date format. Okay, so we need to ensure SP500. Okay, so this is the data frame, the name in R, which is I call SP500. You can have other, for example, you use DF data frame as Nicholas used DF, right? So the date, okay, this column, and this is my name of the data frame, and this is the date. This column, I want to convert this as a date format. Okay, as P500, the same uh, thing, and then format. Okay, format, because you look at this, this is a year, month, and day, right? So I use this uh, day, month, okay, and year, okay. Okay, so this is the format. Okay, I convert it. So I ensure that I make the date type into date. So I had SP500 SC. Okay, now you can see this is the SP500 is the data frame, the name in my R. So now has changed to date, right? So, and the date has been changed to this date format. So now I want to convert it as a time series. Okay, so I use SP500 because I want to use this close this column, the second column, right? The name I use dollar sign and a close, right? And I want to convert it as a TS convert as a time series object. Okay, and here x equals to SP500. Sometimes, yeah, we use x equal to this close, and t equals to SP500, and uh, this date. Okay, and now like what we did in the seminar slides, we want to name this column, this time series, okay? At x.name equals called SP as according to the activity SP 500 weekly average closing price. Okay, so this is what what that mean in the activity. Okay, so now you want to maybe print or head. That's okay. IP 500 and this close. Okay. Now you can see it's a time series, right? Time series, and it is daily data, weekly data. So the frequency is 52. It's not exactly 52, right? Because some years you have maybe 52 times 7 is less than 365 something, right? So it's a little, frequency is bigger than 52 in terms of weekly, right? Okay, so starting from 2000 and 2022. Okay, so this is a requirement of this activity. Okay, yeah, Nicholas, yes, indeed. This means because later if you want to plot this, for example, let's do it here. For example, you want to plot, right? Uh, maybe TS a line plot, right? SP 500 and close. Yeah, you can see the series name will be SP 500 weekly average closing price. So this is what means. If you didn't change the name, then this will say SP 500 close something. Okay, so this is the I think what we mean here, change the time series name. All right, I think this is all for today, right? Let me check whether we have other thing. Okay, yeah, we have one more page. Okay, so do you have any other issues? Any issues when you import the data into R and convert the date column into the date format in R, and also convert the time series into a time series object in R? Are you all okay? All right, okay. So very good. Yeah. So you can all follow these basic operations of R, right? And we do some data preparation. Okay, that's great. Okay, so let me go to the last page, right? The summary of today's lesson. Okay. So basically, we will use R, okay, for this course. And we need to have a data frame. Basically, we need to import data in other format from external file into R, okay? And especially in .csv file. Sometimes you can also read, for example, Excel file. But you will use a different function called, you need to use a package called read XL, okay? Read XL, okay? This package. And then there is a function called read dash XL, okay? Not read.csv, but read dash XL. This function, which you can read Excel data in Excel into R, okay? Yeah. And you import data frames. Of course, the data frame, we can, for example, delete some column. We can change the name of column, right? We can even, for example, remove or add some rules, okay? You can use bind function, okay? Bind function to bind two data frames, okay, in R. So we will not cover here, but you can explore, okay? It's quite straightforward, okay? And we can, of course, some missing data, right, which is NA. And later we will see we can um, use, for example, the average to replace those missing data. Or we can use the interpolation method to fill the missing data. All right, so various ways. But remember, you cannot delete some observations, even if you may have missing data or no observation the value. Because if you delete, then the gap between the observation will not be equal. So it will not be a time series in R, right? So you cannot delete any observations, okay? So of course we can use, remember we use as dot date function to convert the time into date format in R. And we use TS convert function to convert a time series into convert a column into a time series object in R. Okay, later we will so that we can use the functions in TS forecast package to do some analysis. Okay. Okay, today is a very brief and basic introduction to forecasting and R. Okay, so I hope you can do some practice when you prepare for other seminar and also your GBA. Okay, you can form a GBA group now, right, and discuss with your group members to work on the GBA assignment. And do remember, we will not allow free riders. Okay, free riding behavior attitude are strictly not allowed. Okay, so because you are adults and you are pursuing a master degree, right? So you need to cooperate, work with each other, contribute to the assignment. Okay, yeah. Okay, I don't have other things, yeah. Please do some practice with R, and you can search various, lots of useful materials online and learn if you want to learn more, operations, maybe powerful functionalities of R. I do suggest, I recommend you spend some time. Okay, it's very worthy of that. Okay, it's worthy spending time to learn R, to use R. Okay. All right. I don't have any other things to share, and it is almost 10 p.m. And let me know if you have any questions, any problem, any issues. All right. And yeah, you can leave the meeting and enjoy your evening. All right. If you have any questions, you can stay here. I'll be here until 10 p.m. Okay. SHG attendance, Nicholas, I believe it is in the last seminar, right? Not in every seminar. Of course, you need to attend as SHG funding. If you use SHG funding, I believe you need to take attendance. Okay, we still have some